All right, welcome to lesson 10.5, where we're going to be classifying systems of equations. So find me on page 183. And so now we're going to, we've been studying different kinds of equations and how they look in the system. And now we're going to be able to look at them and determine the number of solutions that they have, which you have a little experience with. And based on that, we're going to classify the system as independent or dependent and as consistent or inconsistent. So let's see what that means. When a system of two linear equations in two variables is solved, three possible relationships can occur. The first one is two distinct lines that intersect produce one ordered pair as the solution, the point where they cross. Two distinct parallel lines that do not intersect produce no solutions. And the only third thing that could happen is two lines that are coincident produce the same solution set, an infinite set of ordered pairs that satisfy both equations. So here's a picture of all those three options. We've got option 1, two intersecting lines. They have one solution. It would be right there. We've got two parallel lines. They have no solution, no place where they intersect. And then we have two coincident lines. They have infinitely many solutions because the lines are right on top of each other. So we're going to use this system to answer parts A, B, C, and D. First, we got to write each equation in slope-intercept form. Compare the slopes and y-intercepts. So a little reminder in case we've spaced it. Slope-intercept form is y equals mx plus b. M is the slope and b is the y-intercept. So if I solve that first one, you should pause this and do them yourself. But if I solve that first one, I should get y equals 2x minus 21 halves. And then if I solve the other one, I should get y equals 2x plus 10. So what we've got there are the same slope and different y-intercepts. One y-intercept is 10, and the other one, this one is negative 10.5. So make a conjecture about the graph and the solution of the system. Well, if we have two lines with the same slope, but different y-intercepts, we'll have parallel lines, and they'll have no solution because they'll never intersect. Oops, forget that. Solution. It's hard to talk and write at the same time. Check the conjecture from part B by graphing the system on a graphing calculator. I'm going to let you do that. It's good practice to make sure you can still do your graphing calculator. So you should come out with two parallel lines. I don't think we'll need to revise our conjecture. If you need help getting something in a graphing calculator, make sure you ask later because that's an important skill to be able to do. And then we're supposed to solve, the system using either substitution method or the elimination method and describe the result. So I prefer to do, I guess, I'll just do substitution. Since I know y equals 2x plus 10, I'll just replace this y. So I'll have 2x plus 10 equals 2x minus, and I'm going to turn that fraction into 10.5 right now. So when I get my variable on one side here, I'm going to end up with something like 10 equals negative 10.5. That's false. That's just not true. You remember when your variables all cancel and you end up with a false statement? That means there is no solution. So even if you did it by elimination, you should have ended up with something false, like 4 equals 1 or something like that. So that system would have no solution no matter how you solve it. So number 2 here is a similar problem. First, we need to write each equation in slope-intercept form. So you should pause this and do that yourself. Solve each of them for y. If I do that, I'm going to get y equals negative 2x minus 1 divided by negative 1 plus 1. And if I solve the second one, I'm going to get y equals negative 6 divided by 3, negative 2x plus 1. Again, make a conjecture about the graph and the solution. So these are coincident lines, and they have infinite solutions. And again, try graphing that on the graphing calculator and see if you put them in just like this. You don't even have to solve them for y maybe. And see if you get those coincident lines. And if it doesn't work and you have to put in the solve for y version, go ahead. So then it says solve the system using either substitution or elimination. I guess I'll just use substitution since I already have one solve for y here. I'll put that in right there. So I'm going to end up with the negative 2x plus 1 equals negative 2x plus 1. Hopefully you already recognize that as an identity, but what's going to happen is I'm going to end up with 1 equals 1 or some such true statement, which means there are infinite solutions. So again, I'm going to encourage you to do this yourself before you watch and listen, and then just use this to check your work. But for number 3, we're going to write each equation in slope-intercept form. So I'm going to get y equals 2x minus 6, and I'm going to get y equals negative x plus 6. And without graphing or solving, we're just going to describe the solution in item 3 based on our equation only. So we're not going to look at it on a graph, and we're not going to solve it. We're just going to use our head to just describe how many solutions we even have. So I noticed that these two lines have different slopes. One of them has a slope of 2 and one has a slope of negative 1. So those lines are going to be intersecting. So there will be one unique solution. And my justification is they intersect because they have different slopes. And any lines with different slopes are eventually going to cross at one point. Not more than one point because they don't bend. All lines are straight. So then this says verify using any method. Let's see. Well, I'll do substitution. So if I put this stuff in for y right there, since it's equal to y, I would get 2x minus 6 equals negative x plus 6. And then I would have 3x equals 12, so x equals 4. So my solution is 4, and then I've got to put my x in. So maybe I'll go back to this first equation here and put it right in there. So y equals 2 times 4 minus 6. So y equals 8 minus 6, which is 2. So the solution would be 4, 2. Systems of linear equations are classified by the relationships of their lines. Systems that produce two distinct lines when graphed are independent. Systems that produce coincident lines are dependent. Systems that have no solution are inconsistent, and systems that have at least one solution are consistent. So we're supposed to classify the systems in items 1, 2, and 3. So look back at them and classify it as dependent and consistent or dependent and inconsistent. And each of them will be one of these, dependent or independent, and it will also be either consistent or inconsistent. So write down what you think the items 1, 2, and 3 were, and then see if it matches what I'm about to say. So item 1, that one was independent. They were separate, and inconsistent. They were parallel, so they did not have a solution. In item 2, those were dependent. They formed the same line, dependent and consistent, because they had infinite solutions, and they're consistent if they have at least one. And then item 3, those were intersecting lines, so they were independent, 2 different lines, and they were consistent because they had a solution. So for number 7, we're going to take each of these 3 systems and fill in this entire table. So the first thing we have to do is graph them, and you might want to go off to the side and solve them for y yourself. But for this system here, I would get y equals negative 2x plus 2, and I'd get y equals negative 2x plus 2 again. So those lines would look like this, and they both be on the same line. This one would look like y equals negative 2x plus 2, and y equals negative x plus 3. So negative 2x plus 2 we just did, so we know what that looks like. And the other one would look like negative x plus 3. So negative 1x, down 1 over 1, would look like that. And then this one would be y equals negative 2x plus 2. That one's a popular one. And y equals negative 2x minus 2. So let's see, negative 2x plus 2, that's the one we've been doing. And then negative 2x minus 2 would be down here. So same slope. All right, write the number of solutions. This one has infinite solutions, or infinitely many. This one has one solution, one unique solution where they intersect, and this one has no solution. So the relationship of the lines, these are coincident lines. These are intersecting lines. And these are parallel lines. And if we solve it algebraically, I might go back to standard form. I would have 6x plus 3y equals 6. And on the top one, I might take that first one and multiply it by negative 3. So I would have negative 6x, negative 3y, and negative 6. And what's going to happen is, I'm trying to do elimination here, and I'm eliminating all right, but everything eliminated, and I got 0 equals 0. And that is true, and that's an identity, and that means there are infinite solutions. On the second one, I might just change the signs in the bottom equation in this one so that y's will cancel out. So I would have 2x plus y equals 2, not change the top one. You have options. You could do this lots of different ways. I'm just changing the signs on the bottom equation to eliminate my y's. And I would get 2x minus x is x, and 2 minus 3 is negative 1. So x is negative 1, and then I'll plug it back in, maybe to this bottom one. So negative 1 plus y equals 3, so y equals 4. So my solution would be negative 1, 4. And then for the third batch, let's see, I might multiply the top equation by negative 2. So I get negative 4x minus 2y equals negative 4. And then on the bottom, I would still have 4x plus 2y equals negative 4. And my x's and y's are going to eliminate, and I'm going to end up with 0 equals negative 8. Don't be careful not to cancel these out. They don't cancel if they have the same sign. So that's false. And we know that that means no solution, right? So no solution. And this one was infinite solutions, or IMS, infinitely many solutions. And then we write them in slope-intercept form. Well, we already did that earlier, so, oops, I'm going to have to write smaller than this. Y equals negative 2x plus 2, and y equals negative 2x plus 2. And this one was y equals negative 2x plus 2, and y equals negative x plus 3. And this one was y equals negative 2x plus 2, and y equals negative 2x minus 2. Compare the slopes and y-intercepts. So these have the same slope and the same y-intercept. These two have different slopes and different y-intercepts. And these have a same slope, but different y-intercepts. Classify the system. So if they have the same slope and the same y-intercept, they are the same line, so that is dependent. And it has no solution in that case, so it's inconsistent. And this one, they have different slopes, so they are two different lines, so they're independent. And two different lines have an intersection point, so they have one solution, so they are consistent. And then these two have the same slope, but different y-intercepts, so they're different lines, so they're independent, but they're parallel, so they don't have a solution, so they're inconsistent. And I made a mistake right here on this one. These guys, they do have a solution. So this one is a mistake. This is consistent. I just noticed that when I wrote the last one. So this is dependent and consistent. Hopefully you caught that mistake and you were going to bring it up to me before I changed it. All right. So both of the ones that have solutions are consistent. This one and this one. And then the third one is inconsistent. And then the two that have two different lines are independent. All right, that's everything on that table. So that table would be really useful to study. You want to be able to understand just by looking at a graph, or just by looking at the equations, or by algebraically solving. Either of those, any of those methods produce the same information and the same results, and you want to be able to look at one thing and tell all of that stuff. But you can reinforce your thoughts and verify them by, if you look at a graph and you think it's got infinitely many solutions, then you should get an identity when you solve it, so you can see how all of that stuff is interrelated. So bring any questions to class and we'll pick it up from there.